So hi everybody. Now, for people who don't know me, my name is Jung. So obviously I teach physics. All right. Now, so in today's 2-hour session, what we're gonna do is we are going to the most important thing about momentum is momentum consists of 50% calculation and 50% theory. So that's why this makes this subtopic a very high potential to come out in your essay question, especially for your Form 4 midterm exam. Okay, so what is momentum? So momentum is actually this thing called the mass times velocity, which is your kg times meter per second, because mass is kg, velocity is meter per second. So you multiply this thing, you get kg meter per second, kg ms -1. Oh. Okay, no problem. Okay, so now, before we even go into the formula, the first thing that you need to know is there's this thing called the principle of conservation of momentum. So they say when two or more bodies act on each other, okay, the most important, the climax of this definition is you need to know that their total momentum remains constant. Of course, provided there's no external force acting on it. So what do you mean by their total momentum remains constant? So constant means, let's say for example, Jung punya height remains constant. Means if today I am 180 cm, tomorrow, next year, 10 years later, I'm still 180 cm, right? So remains constant means whatever before will be equals to the total momentum after. So their total momentum remains constant means before equals to after. Okay, so once you know this whole entire concept, then only you berlayak to talk about the formula. Okay, in this formula, usually when we see a lot of teachers, right, when they teach elastic, inelastic, and explosion, okay, they'll write down all the formula, tell you how to see. But for me, I want to use a different approach. Okay, first of all, let's look at the formula first. Okay, do you all agree when I say the elastic and inelastic is actually the same? Do you agree if I say elastic and inelastic is actually the same? Okay, let's see. Your M1 U1, M1 U1, same law. M2 U2, M2 U2, same law. Okay, on the right hand side, if you see here, there is a bracket. There's a bracket. Now, kenapa there's a bracket? Now, when I multiply this bracket out, okay, imagine if I take this M1 and I multiply by V, I take the M2 and I multiply by V, I'm going to have M1V plus M2V. So I'm going to have M1V plus M2V. So which is M1V, M2V. So first of all, you have to understand that these two formulas are actually almost 99% the same. The only difference is this one got the bracket. And why got bracket? Because they have for inelastic, because they have the same velocity. So when you have the same velocity, you can actually factorize. So therefore, that's why there is a bracket. Okay. So why would they travel at the same velocity? Oh, very simple. Because they actually move together. So the idea is from the formula, we try to understand what is happening to the object. So this is actually M1V plus M2V. So move together lah. Okay, Ken? So far for me, I will say these two formula is very similar. Okay, then we look at, so which means that elastic object didn't move together lah. Tidak move together lah. They move together. Okay, so they separate. Now, what about the third one? So we talk about explosion. So insan, explosion, the criteria is what? In order to get explosion, your criteria is, your 条件 is, okay, I give you a hint. The front part here kosong. Okay, so if the front part here kosong, what does it mean? Now, so which means that your initial, okay, because this is actually your starting, you must start from rest. Okay, meaning to say what? An explosion must start from rest. Okay, a lot of people thought, right, explosion means that, okay, let's say an object, one thing move here, the other thing move, that means they move opposite direction. Bukan. Explosion is, you see, it is the only formula that has this zero. So which means that explosion must start from rest. There's no velocity at the start. Then at the end, you will form one positive and one negative value. Okay. Now, for more info, we will do a calculation later. Okay. But before I start, okay, I just want to show you two sample calculation. Okay, guys, you don't have to copy this thing because we're just gonna warm up a bit. All right. Okay. So first question. Now, if today Jung Hao is standing on a skateboard, and I am moving with the skateboard at a velocity of 4 meters per second. So I'm like sliding on the skateboard muscle. So 4 meters per second. So Jung Hao is 60 kg. The skateboard is actually, let's just put the skateboard is 5 kg. So now I'm sliding with the skateboard. So after that, if I jump, with like a lot of energy, if I jump forward, so obviously the skateboard will move backwards as I jump forward, correct? So when I jump forward with 6 meters per second, how fast will this skateboard travel backwards? How fast will this skateboard travel backwards? Okay, so first of all, what is our strategy? Okay, when we look at this question. Now, so most of the time, a lot of teachers will say, lah, okay, first you have to differentiate, is it elastic or is it inelastic or is it explosion? Okay, so first question, we look at this system, guys. Since this one, the Jung Hao and skateboard question, can I say this is an explosion? Yes or no? Can I say this is an explosion? Yes or no? So Danesh said no. No. Mingsa said no. Axel said no. Yeah, the answer is obviously no. Okay, why not? Because initially you have already have velocity. Now, if you go and suck this kosong into here, gone. Your whole thing, you will get 0 marks because it didn't start from rest. Okay, so what is the safest formula to use? Okay, because guys, later in exam you panic, right? So which is always the smartest and the safest formula to use? No, Ganesh, the answer is actually the first one. Remember, guys, this is your general formula. If you panic, if you don't know how to differentiate, guys, always use elastic. You will never go wrong. Okay? Why? Okay, let me show you. Okay, because it's elastic, right? Very, very convenient one. I don't know how to differentiate this is elastic or inelastic or explosion. So I look at this. This one look like explosion, but also look like inelastic. Tapi you always use the general one. Okay, so watch how I write this. Okay, because it is before equals to after. So before is always mu, mu. Okay, why mu is before? Because u stands for initial velocity, the starting. And then after that, here I write mv plus mv. Why become v? Because that's the final velocity. So starting equals to final. So the first object, then the second object, the first object, then the second object. Okay. Now, sometimes in exams, when I first learn this thing, right, I don't even write 1 and 2. I write, okay, so this is the Jung Hao object, this is the skateboard, this is the Jung Hao object, this is the skateboard. So I know who is the first, who is the second. Okay. So first one, mass times velocity. Now I revise with you. Momentum is always mass times velocity. So when we look at this thing, it is always your mass times velocity because Jung Hao riding the skateboard 4 meters per second. Okay, then after that, plus 5 velocity. Okay, guys, if I ride a skateboard, if I hop on the skateboard and I move with the skateboard, so this skateboard consider moving or not? Consider moving or not, the skateboard? The answer is yes, of course, okay, because it will move together. So therefore, this is also 4 meters per second. So common mistake is people thought that when I jump on the skateboard, I'm moving at 4 meters per second. The skateboard is not moving. No, if these two objects move together, they share the same speed. Okay, so 6 times 4, 5 times 4. So why? Because it's mass times velocity plus mass times velocity. Mass times velocity, mass times velocity. Okay, equals to next. So Jung Hao punya mass berapa? If I jump out, I will still have the same mass, right? So 60 kg plus 6 multiplied by 6. 6. So then what's the mass of the skateboard? So skateboard is 5 kg, right? So 5 kg V. Okay, can you do me a favor now? Help me to calculate how much is this V. Okay, we're gonna calculate together. Okay, but you do your calculation now. Okay, I just want this early morning, right, to kasi your otak exercise a bit first. Okay, so if you realize this calculation, you will get a very special answer. You get a very special answer. Okay, whatever that is on the left hand side, this is 260, this is 360 plus 5V, right? So your V becomes, yes, Axel, thank you very much. This is negative 20 meters per second. Okay, can you tell me why this velocity is negative? Anybody? Why is my answer negative? Yes, because now your skateboard at the end are moving ke belakang. Your skateboard is now being like kicked forwards, right? Correct. So therefore, when you kick yourself forward, the skateboard moves backwards. So you get negative answer. Okay lah, justify lah, no problem lah. Okay, Ken, no problem lah. Yes. So this is how you will get this negative 20 meter per second as the velocity. Okay, so this is my sample number one. Okay, what do you learn in sample number one? If not sure, if you don't know how to differentiate elastic inelastic explosion, always use the general formula, which is the elastic one. Okay, use the general one. Okay, I give you a second situation. Okay, one day, Jung Hao is driving a car. Okay, then suddenly, this is Jung Hao driving, suddenly can put the 6 ms as negative since velocity going in the direction. Okay, so Regan, usually what we do is when we look at a question, right, we will decide we want to put, let's say, which side is positive. So most of the time, I will take everything to the right as positive, everything to the left as negative. So since this guy jumped to the right, according to my picture, so I prefer to put this to be positive 6. Then this come out negative means he moved opposite direction. No? Okay. So let's say, Regan, if you put negative 6 here, okay, your final answer will come out to be positive 20, correct? So means that according to your picture is you go towards the back is positive, you go towards is negative. Is it acceptable? The answer is yes, it is also acceptable. It's just your own preference only. Okay, can, yeah. So it's your own preference only. Okay. Fun fact, okay. Now, English people, which is British, okay, you all know, like we all follow UK English one, right? Like UK, like we all England one, right? England people, which is British syllabus, we always take here positive, here negative one. But America syllabus, right? They like to use here positive, here negative one. Very weird one. Yeah. Okay. So that's why it is also acceptable. Okay, can now, so okay, next question. So if today Jung Hao one day driving on the road, okay, so imagine me and my car is like 120 kg up. So my car is like my size only. Then after that, suddenly I saw my friend Wailun crossing the road. Okay. So Wailun is only 80 kg. So suddenly, as he's crossing the road with 1 meter per second, because I was speeding, so I was driving at like maybe 9 meter per second. So suddenly I langgar him. Okay, once I langgar him, what happened to Wailun? Okay, so he actually hugged my car. So what do you mean by hug my car? Means he actually got stuck to my car, and then we moved together with a velocity v. Okay, so for this one, basically if you experience, you think out this one, teacher, very simple lah. This one move together kan, because the Wailun hug my car and then we move together. So obviously this is inelastic collision, correct? Now, let me ask you a question. If I accidentally use elastic formula to count inelastic, boleh ke tak boleh? Okay, I know that this is inelastic because it is stuck together. See, they stick together, move together. But if I accidentally use elastic punya formula, is it acceptable? Can or not? Axel, what do you think? I accidentally wrote wrong formula. Can gua. Okay. So we see. Boleh. Okay, I know also say can. Okay, let's try lah. Okay, try and error lah. Okay. Wow, Bernice. Semangat wey. 很好 Okay, now. So in this case, you will see, okay, I accidentally, because I careless, I write M1U1, MV plus MV, your M1V1, M2V2. Okay. So I accidentally wrote this. This is Jung Hao. This is Wailun. This is Jung Hao. This is Wailun. Okay. So the mass of Jung Hao is 120 kg, velocity 9, mass is 80, this one is 1. Okay. So what we did here was we just do mass times velocity equals to sekarang after the accident. Jung Hao is still 20 kg, 120 kg, right? Wailun is still 80 kg, right? So if I write 120 V, because mass times velocity plus mass times velocity, I will also get 200 V, because you see, once the V same, automatically when you do the working, right, you will automatically add them up together. So sebenarnya, the first formula and the second formula is the same. If you actually rewrote separate, once you share the same unknown, you will add them up together. So ultimately, you get back the same answer. So what am I trying to remind you here? What I'm trying to remind you here is actually, don't be too concerned about which formula to use. Don't be too concerned about which formula to use, because either way, if you use the first one, it's always the safer choice. Okay, Ken? So if you use the first one, it's always the safer choice. Okay, so we now warm up with the calculation already. Okay, so are you ready to look at the next question? Can I? Boleh ah? Okay, Jung, let's look at page 9. Okay, let's look at page 9. Okay, on page 9, you will see here, okay, this is a space vehicle moving about to dock with a space probe. So they try to make it sound like very wow, very complicated, but actually very simple one, okay, space probe, whatever. So from here, we realize that they will share the same velocity. Why? Because they, after docking, they move together at 0.2. So can you tell me what type of collision is this? What type of collision is this? Answer is yes, correct. So in exam, I must write full, right? Inelastic collision. Don't just write inelastic. Okay, can inelastic collision. So based on the information provided, calculate the total momentum of the system. Okay. So like now we see here our what is our problem? Okay, you will realize that space vehicle and space vehicle and space probe, 2,500 kg, 1,500 kg. So can I label here first? Space vehicle is 2,500 kg. This is 1,500 kg. I don't have the velocity here. Okay, I don't know how much this V is. Okay, total momentum of the system. Okay, guys, my masalah di sini is I don't have this velocity. How can I find the total momentum of the system? Anybody got any suggestion? How to find that V? No, not to use Suvat. No, no, no. You see, I got this mass, I got this velocity, but I don't have this mass, I don't have this velocity. How? Okay, because you see, if I try to calculate the total momentum of the system, so it's the space vehicle, SV space vehicle and space probe punya momentum add together, right? Correct? SV is space vehicle, space probe is SP, this is SV. Okay, so if I take the mass times velocity, you will see that this is 2,500 kg, this is 0.5. If I plus this 1,500 kg, my velocity is unknown. I don't know that velocity. So how to find the total momentum of the system? Anybody can help me with this? Okay, actually, if you do this method, you cannot find the answer one. So this is where you need to use a bit of physics concept. Okay, ask you a question. Just now we mentioned about the principle of conservation of momentum. Okay, what was principle of conservation of momentum? So what was it? So this is where you need to use theory to support. What is the principle of conservation of momentum? Yes, very good. It means that your before punya momentum and your after punya momentum is the same, right? Okay, which means that your before punya momentum and your after punya momentum is the same. So how do I find the before momentum? Okay, I cannot find before momentum. Then the strategy is I calculate after momentum because I cannot find the before. Can I find the after momentum? Can. My space vehicle 2,500 kg, my space probe 1,500 kg. So now they stuck together already. So kalau they stuck together, you consider as one object. So what you can do is there's two ways to write. So you can write 2,500 multiplied by 0.2 plus 1,500 multiplied by 0.2. Ataupun you can just straight away write both add together, which is 4,000 divide 0.2. So since I cannot find before, I can find after. So my momentum here is actually 800 kg meter per second. Okay, 800 kg meter per second. Okay, can Okay, if you got no problem, then we are going to go to the next part already. Can? Okay. Now, so 800 kg meter per second. Okay, then you all know the unit y kg meter per second, right? Because tadi we say is mass times velocity. Okay, speed of the space probe before docking with the space vehicle. Okay, now we have to calculate this velocity already. This one. Okay, we want to find the before punya velocity already. Okay, how to find the before velocity? So now we're going to use back the same strategy. Okay, my before, which is equals to my after momentum, right? So my after momentum, I calculate out to be 800 already. So you see, guys, what I'm trying to tell you, right, is walaupun you can memorize formula, however, sometimes the question, right, they will pushing. You cannot directly straight away use formula. Like sub formula, sometimes will not get the answer. So you see, they want you to test, do you know the principle of conservation of momentum before equals to after? So my before momentum is going to be my mu plus my mu lah. Okay, because the after, the mv plus the mv I calculate already. Okay. So my mu here is actually 2,500 kg multiplied by my initial velocity 0.5 here. Okay, multiplied by the 0.5 here, plus 1,500 times the initial velocity starting. Okay, then after that, when I calculate this out, Regan, my answer should come out to be how much? Yes, Excel, I think your answer is correct. You get this to be negative 0.3. Okay, why is it negative? Again, because you look at the picture, this thing is moving in the backward direction. So there has to be a reason why that thing is negative. Itu saja. Okay, can, all right. Okay, after that, you see, they want you to state and explain the principle involved in your calculation. Okay, sometimes why memorizing definition very important. Okay, so I purposely put the definition here. So you will see that, teacher, do I need to write the definition? Yes, because if they want you to explain the principle, this also means that you are actually required to write the definition of the principle. So the best and the smartest way to do is try to remember this momentum punya definition, conservation of momentum punya definition. Okay, so what's the rule that we use here? This is actually your principle of conservation of momentum, so that your total momentum remains constant provided that there is no external force acting on them. Okay, so like I said, the most important part of the definition is the kat belakang here. So the bottom, the front part, of course, if you can remember, try to write lah, but at least remember the total momentum remain constant. Or some teachers will also accept the momentum before and after is the same. Okay, I'll give you all 10 seconds to write this. So quickly then we will do some theory question. Quickly then we'll look at some theory question. So far everybody doing well? Okay, may I know, right, like how many of you here are usually, like today is your first time attending my class? Like anybody here like first time attending my class? Yeah, Danish, obviously. So which school are you from? Yeah, actually it's like not considered because you watch video so okay lah, still my student okay. Oh, Bukit Bintang, all right. Okay, can now, so let's look at page 3 once you are done. Okay, so far, if you do enough physics question, right? Okay, guys, at one point, how to know whether you do enough physics question or not? You will realize, can go back okay, belum habis lagi very slow leh. Okay, wait it's your man, right? Okay. Okay, can learn. Okay, so we go and see page 3. Okay, we go and see page 3. Now, page 3. Okay, at page 3, you realize that, okay, if you do sufficient, like, cukup physics question, right, you will realize that the most headache part is what, the most headache part is explained. Okay, is explained. Basically, it's a bunch of theories. So not the calculator paling headache, it's the explain paling headache. Okay, you see, do you know why there's a M1, M2, M3, M4 here? Do you know why there's a M1, M2, M3, M4 here? Because the M1, M2, M3, M4 actually means the first mark, the second mark, the third mark, and the fourth mark. All right. So, teacher, do I need to memorize the whole entire explanation word by word? Need or not? Do you need to memorize every single word or not? Okay, the answer is no. As long as you can explain the main point, like what is the keyword here, cukup, good enough already. Good enough already. Okay, let's check what do you mean by keyword. Okay, so first of all, we see this is a rocket. Okay, to explain this thing, basically you always have steps. So why rocket can fly up? Biasanya is because inside the rocket, there's a burning. So what do they burn? So obviously they burn petrol. So the fuel is mixed with air in the combustion chamber. Okay, let's say in exam, because you forgot the word combustion, you mungkin terwrite the burning chamber. Okay, I didn't write combustion chamber, I wrote burning chamber. Guys, acceptable or not? If I wrote burning chamber, if you school teacher, you accept or not? Usually the answer is yes, because combustion is burning, burning is combustion, so can okay. But combustion is the more proper word, so we try to learn combustion. But if exam for you, right, just write burning chamber, okay. Okay, so once you burn inside, explosion occurs. Then it produces hot exhaust gases. Hot exhaust gases is you see, right, when you launch a rocket, there's like a fire, that one, right, correct? So it produces hot gases. Okay, then after that, so the first part is I talk about the burning process. Number two, the hot exhaust gases will move downward with high velocity to produce a high momentum. So this thing will go down with a high momentum. So the rule says that if you throw something down, something will go up. Imagine if today I stand on a skateboard, if I throw something forward, me and the skateboard will move backwards, right? Correct? So this is due to the principle of conservation of momentum. If you throw something forward, you will produce a backward momentum. Has to be balanced, okay? So hot exhaust gases move high velocity, produce a high momentum. So the third part is usually the M3 is always the definition. So this is berdasarkan what physics principle. So that's why I said the physics conservation of momentum. So this conservation of momentum, total momentum is always conserved. Conserve means that before equals to after. Then after that you say, so therefore it will move upward with equal but opposite direction upward momentum. Okay, now, so this one, all right, try to remember the sentences. Okay, so if today I teach you rocket, do you know how to do jet engine? Okay, I want you guys to compare these two answers. Okay, compare the answer, guys. Is it the same or not the same? Same or not the same? 一样吗? Same. Okay, see, we check first. So the first part I talk about the explosion occurs, I produce hot gases, combustion chamber. Means I burn something. When the air is mixed with fuel inside the combustion chamber, oh yeah, so the burning starts, explosion occur, then therefore you produce gases. So the first part is the same. Number two, the hot exhaust gases, then this is a large backward high speed, high velocity, backward momentum. This is high momentum, downwards. Is it the same? Also the same. Betul. The third one, according to the principle of conservation of momentum, according to the principle of conservation, total momentum is constant. Acceptable or not? Is it the same or not? Yeah, it's exactly the same. Every word also the same. Fourth, it will opposite direction upward momentum, opposite direction forward momentum. Why? Because jet engine is actually the aircraft, the aeroplane jet engine, whereby it will suck air in and then it will push air out. So when the aeroplane suck air in and push the air out from the back, it will result in your aeroplane moving forward. Okay, so this one is when your air is being pushed down, your rocket will end up move backwards. So it's an opposite direction momentum. So if we look at this thing, they are actually exactly the same. Exactly the same. Okay, Now, so we go back to page 9. We go back to page 9. Okay. Now, without looking at the front page, okay, I'm going to give you like a bit of a rangka karangan like that. Okay, so we got the M1, then we got the M2, we got the M3 and M4. Okay, can you tell me what are the most important thing in M1? The first one, M1. Okay, we have to say what? Agak-agak. So I want to test whether your brain can retain those words or not. Okay, yes, correct. So the first part we're gonna say the fuel mixed with air lah. Fuel mixed air. Then after that, apa lagi? Yes, correct. You must talk about the combustion. Okay, so it mixes in the combustion chamber, then you have the combustion. Okay, then what happens? Okay, that rocket go up one, then what will you get? Yes, correct. The word explosion, very important. Okay, the word explosion is important. People tend to miss out the word explosion. Okay, then after that, you can put your hot exhaust gases at M1, ataupun you put your hot exhaust gas at the bottom part here pun tak apa. Okay, so you how about, okay, so you have the hot exhaust gases produced. Okay, so what about your hot exhaust gas? Apakah like so special about it? Okay, yeah, I got hot exhaust gas, so okay, because your rocket. Right, correct. So at the end, what about the hot exhaust gas? Okay, it is being released at a higher velocity to produce downward momentum. Okay, can? So high velocity, so you produce a higher downward momentum, a very large downward momentum. Okay, can? Yeah, so you see now, in fact, today, I want you to start remembering all these words because most of you have exams coming up lah, except for the Kajang people lah. Okay. Now M3, the third one. For M3 is what? Just like I say already, M3 is we have to explain how this thing works. We're gonna write the principle of your conservation of momentum. So principle of conservation of momentum, oleh itu apa berlaku? Your definition. Okay, so which is the total momentum remains always conserved. Okay. Lastly, we will say that, so therefore your rocket push upwards due to an upward, sorry, equal but opposite momentum. Wait, why my pen is doing such a okay. Equal but opposite upward momentum is created. Okay, but equal but opposite upward momentum is created. Okay, can, all right. So therefore, this is what you will get. Okay, go up. This is equal but opposite. Equal but opposite upward momentum is created. Okay, can? Yeah, so this is what you will get. Okay, can? All right, yeah. So if you just check this out, you will realize that this is actually quite interesting. Because Takisara, okay, on the next page, you will have jet engine and all the other line punya question. Okay. Now today, we still need to go a bit faster, guys. Okay. I want you to look at this question. Page 16. Okay, page 16, 16. Okay, one of the worst exam question that can come out. Okay, why I say worst because it's very difficult. Okay, is try to look at page 16. So Winston, if this one come out, wow, lucky you. Okay, this is a water rocket made by a student. Because today we do before. Okay, you are required to give some suggestions on how to modify the water rocket so that it can travel a maximum horizontal distance. Using the knowledge on forces, motion, and properties of materials, state and explain the modification based on the following aspects. So, water rocket. Okay, if you are lucky, your school actually let you all do this experiment. In fact, certain schools have water rocket competition. Means you will pump this water rocket and you see whose water rocket can travel the maximum horizontal distance. Okay, so this one, the aim is you have to launch this rocket as far as possible. Okay, so using the knowledge of forces and everything. Okay, this adalah salah satu contoh of my soalan essay. How many marks is this essay? This essay is actually 10 marks. Okay, this essay is actually 10 marks. Okay, this part only. Okay, but I want everybody to stay at this page. Okay, because right, how many of you, your school teacher never teach you do essay? Never. Never. Never do essay. Okay. Because essay actually got two types in Java. Got type A and type B. Okay, you all look at this water rocket essay. Okay, and then I show you another one more essay. Okay, another one more essay is this one. This is also an essay question, 10 marks. Okay, can you tell me what is the difference between this essay and the water rocket essay? What is the difference? Okay, this one, the main thing here is you are trying to determine the most suitable wheelchair. So meaning to say, Jung Hao call this the choose essay. Meaning to say that at the end, you have to give conclusion. Therefore, I will choose P or Q or R or S. Okay, so this the main concept here is choosing. Now, for water rocket, it's harder. Why? Because this one is actually Jung Hao call this as designing. So we have choosing and we have designing. Different one, different one. Okay. Now, choosing and designing. So design means you have to write everything by yourself. Okay. So let's try. Okay, which one harder? Of course, design harder lah, because they never give you any chiri. Alright. So like Ichi, let's write this thing. Okay, I start off with the easiest one. Okay. Explanation, characteristic, and explanation. Okay, guys, can you tell me what is the angle of launching? Okay, this one is very simple. So, Jeshri, Jingyan, Wayan, angle of launching, how much? Okay, I give you all a hint. Your punya era got play Angry Bird one. Do you guys know what game is that? Okay, if you play Angry Bird before, do you know how can we launch something through a maximum horizontal distance? Also known as, I want to go further. Okay, what angle should I launch this rocket? Okay, the answer is, okay, let me draw this out. Because most people ask me, how teacher, why? Okay, if you launch a rocket, or if you play Angry Bird before, you launch the bird out, right? If you put too high punya angle, if let's say this angle is too high, what will happen is this thing will just boom like that. Okay, if this is too high lah. If it's too flat, you will get like boom, straight. It will straight away land because you don't have enough distance for it to travel. So the best is you have to launch at 45 degrees. Then you will realize that this is actually further. So the jawapan here is the angle of launching is 45 degrees. Okay, now we write the angle of launching first. Okay, so the angle of launching is 45 degrees. Okay, why 45 degrees? Maybe I need to change my direction. Why 45 degrees? Because this will the rocket can travel longest horizontal distance. This is where your rocket can travel the longest horizontal distance. Okay, so okay, 三项. So once I do this, I get 2 marks already, guys. Very simple. 45 degree, travel longest horizontal distance. 项. Okay. what should be the shape of the rocket? So if today I want to make a, I'll say like a water rocket, right? Correct. So how much, what should the shape of the water rocket be? Cone shape is not acceptable. No lah. Cannot cone shape. Guys, what shape? Danish, very good. Okay, the answer is, yeah, Chloe. Very good also. So the answer here is we are looking for aerodynamic shape of rocket. Yes, very good. So aerodynamic shape standard are why aerodynamic shape? So that you can reduce air resistance. So if you reduce air resistance, so that you can accelerate higher acceleration. Okay, so therefore that aerodynamic shape. Very good. Next, this one also set already. Which one easier? Oh, material use also very easy. So guys, what about the material use? This one, walaupun the material use is very easy, people will tend to get it wrong the first time. So like Bernice, what's the material use for the water rocket? Anybody? Regan? Jai Yi? Okay, I give you a choice. Okay. Should I write plastic? Or should I write like, should I name the material? Or should I write the characteristic of the material? The answer is, but because plastic is light, so we always write characteristics. Okay, don't write the name of the material. Describe the material. Remember, you are supposed to say the properties of material. So the biggest common mistake is people go and name the material. Okay, I ask you a question. Example, aeroplane, rocket. What material do they use? It's like what aluminium and ferrum composite called duralumin. You don't even know the name. So in SPM, right, they don't expect you to name the material, but you have to tell me that the material need to have what characteristics are like these are durable, stronger and everything. Okay, Ken? Now, however, for light, we also don't recommend you to write lighter because usually material use, we need to talk about something called low density material. Light is the explanation. So a lower density material, okay, we'll say lower density material, punya advantage means that it has a lower mass. Therefore, it is lighter. Lighter is the, how to say, final explanation. Lighter cannot be used as a characteristic. Remember, lighter cannot be used as a characteristic. It has to be an explanation. Low density material can be a characteristic. Okay. Now next, volume of water a bit complicated. Okay, we talk about the additional structure first. So guys, in order for your water rocket to travel, okay, Mole, what additional structure do you need to add to the water rocket? What additional structure do you need to add to the water rocket? Okay, Ganesh, Ganesh, you do this before. It was so smart on you. Okay, now, this is called what, guys? This one. What do you call this as? Okay, usually you can call that a wing, but to be more exact, we call it as fins. We call that as fins. Why? Okay, you know fish? Okay, guys, you all know fish. Fish has the top part and the bottom part like that, right? Correct. So that's the fins of the fish. Now you know, right? People they like to eat shark fin soup. So what they do is they go and cut off the top part of the fish, of the shark part. So once don't have this fin, right? What will happen to the shark is the shark will now like that, it will now rotate. Because this fins is for them to balance. So the same thing applies. When this rocket okay guys, imagine when this rocket fly upwards. Do you want your rocket to spin or not? Do you want your rocket to spin as it moves? When it spins. Is spinning a good thing? The answer is no lah. Okay, why is it bad? Because if you go up, when you spin, you actually waste energy to do the rotation. So we want the rocket to fly like fly upwards, don't spin up, go, don't pushing. So the fins put additional fins on the rocket. Okay, why do you want additional fins on the rocket? The answer is because to prevent rotation of rocket during flight. Okay, during the flight, prevent rotation of rocket during flight to ensure higher stability. So that is more stable. Okay, yeah. Okay, Ken. Now, once you are done with all this, okay, we look at number 4, the volume of water in the rocket. The volume of water in the rocket. Okay, now, guys, why do we need to add water in a water rocket? Why do we need to add water in the water rocket? To give pressure. I can pump air, Danish. I can pump air. Air also got pressure. Then it will also launch the rocket. Prevent the air from escaping. No lah. Okay. Yeah, I know. You're right. Okay, the answer is actually something to do with when I put water into the water rocket. So when bukat, right, this mass of water, this mass will be higher. So when you have larger mass, larger velocity, your backward momentum actually increases. If your backward momentum actually increases, if you produce larger backward momentum, so your rocket, boom, go down, right? So what happens is that your rocket can actually fly higher. So you need to add water. Okay, because you have a larger backward momentum. Okay, but then now this question is, guys, how much water do I need? Do I want to add sampai maximum? Do I want to add sampai like maximum? Or do I just add like probably a little bit? How much water do I need? Okay, so this one, now the answer is usually 1/3 of the volume of the total. Certain books, they say 1/2, means half. But I checked with it, very sure. 1/2 is wrong. 1/3 is correct. Very sure. If you don't believe, you can go Google. Okay, Ken? So please, guys, if next time you see 1/2, your friend is wrong. Okay, 1/3 baru correct. Very sure. Selangor State paper came out this question before. They also say 1/3. So this one don't need to argue. Cannot argue. It is 1/3. Okay? Now, so let's have a look. Okay, so what about the volume of water in the rocket? So the water volume is 1/3 of rocket total volume. The volume is 1/3 of the rocket total volume. So why? Because what we are trying to achieve here is the water can produce larger backward momentum, but not too heavy for rocket to fly. Okay, meaning to say that you need to add water to produce a larger backward momentum. Okay, but it cannot be too much, because when there's too much, then the rocket very hard to fly, because why? Too heavy already. So in this case, we are looking at this. We don't want it to be too heavy for the rocket to fly. Okay, we don't want it to be too heavy for the rocket to fly. Okay, Ken? Faham? Okay. So momentum done. All right, momentum done. In order to, okay, my aim is today, at least you spend 2 hours, right? I can help you to revise 2 subtopics. So in the event that your exam, maybe some of you have exams next week, some of you have exams next month. at least your momentum like sudah habis. All right. Now I want you to look at page 10. Okay, promise me that before your exams, you're gonna write this jet engine and look at this essay question again. This is the choosing one. Okay. So once you do this jet engine essay question, this one, the bottom one, page 10, and you do water rocket, your momentum should be quite good already lah. Okay, your momentum should be quite good already lah. Okay, can. Okay, very good. So once you're done with this thing, okay, I want everybody to just look at a easier question. Now, screenshot yang mana? Which one? The rocket one, is it? Oh, okay, wait, hang on. Okay, guys, if you tak sempat to this, you can also screenshot this. All right. You agree this is one of the most hardworking holiday you all have ever had? School holiday. But every morning you got seminar. Oh, very hardcore. Okay, now. Okay, so once you're done with this thing, okay, remember now, page 10 must do before exams okay, must do before exams page 10 okay, once you're done with this thing, okay, Joe, let's do something easier. Okay, let's do something easier. Kasi cool down a bit first. Okay, let's go page 7. Page 7. Okay, page 7. Okay, this is a displacement graph. Okay, now why I want to do displacement graph is because of the Bernice they all exam come out displacement graph they don't know how to do guys. I'm like want to heart attack already, you know. Okay, now I want everybody to teman me and do this question right now. Okay, like put down everything, you look at this question with me right now. Okay, so this is a displacement time graph. Okay, now so in exam a few graphs okay, we got displacement time graph, which is called ST graph. We got velocity time graph, VT graph. We also got acceleration time graph, AT graph. The more common one in your exam is usually velocity and displacement time. Okay, so you need to be very good in these two graphs, velocity and the displacement time graph. Okay, so jom kita tengok. Okay, the trolley takes how many seconds to travel from P to Q? How many seconds to travel from P to Q? Okay, kita tengok. From P to Q, it is actually 8 meters. From P to Q is actually 8 meters. So it starts at P. So from P to Q, it goes all the way to 8 meters, right? So how many seconds did it took for it to travel from P to Q means to 8 meters? The answer is 5 seconds. Okay, now Bernice, now this is your chance to 赎罪. Okay, next. What's the displacement of the trolley when it is at R? What is the displacement when the trolley is at R? Okay, see this 升天. Okay, this is 0. He went all the way to the front, then he go all the way to the back. So this is your starting point. This is your ending point. Your ending point is behind, belakang you. All right. Now, where did this whole object end at the end? End at the end. At -5, right? So the total displacement is going to be -5 meter. Okay, can all right, okay. So berdasarkan this question, remember, if I ask you for the total displacement versus if I ask you for the total distance, it is actually a different thing. Okay, what is total displacement? So total displacement, they care about the starting point to the ending point. So now this is belakang. I don't care you move forward ke, backward ke, whatever. I want to care where you start, where you end. If you end behind of the starting point, that is considered negative direction. So my displacement here is -5 meter lah. Okay, Ken? Now, how much is my total distance traveled? How much is my total distance traveled? Okay, I know it's correct. Yeah, I know it's correct. Bernice is obviously wrong. Okay, 生气。来，快点 Sarah, Eva, Chloe, Jimmy, Kaden. The answer is, okay, because you travel all the way forward, so this is 8 meters. You travel all the way backwards, so this is another 8 meters. Right, because you move forward 8, you come back 8, then later you move all the way back to R, right? So this is another 5 meters. So jumlah, guys, jumlah total. How much did you move? 8 plus 8 plus 5. 8 plus 8 plus 5. So therefore, this is actually 21 meters. Okay, make sense? Right? Is this difficult? Because I got one school, right? Okay, the Kajang school, okay. What happened was, right, everybody in the, like, so many of the schools say, well, teacher, this distance not very hard, or you how to see how to see the total distance. So if you try to picture it, if you move 8, then you move 8, then you move 5, then you get 8 plus 8 plus 5. So this is not difficult, right? Danish, it's not hard, right? Kan? Not difficult at all, right? Okay. Now, so yeah. So okay, what is the velocity of the trolley when it's moving from Q to P? Q to P. Okay, guys, where is the Q to P? So the problem here is you need to know where is the PQR berdasarkan the graph punya line. So I start from P, I go to Q, I end at R. Nanti from Q all the way to R, I will pass by P. Correct? I will pass by P. Farm, right? I'll pass by P. So from Q to P, what is the velocity? Okay, guys, I write like this. You tell me correct or wrong. Okay, from Q to P, I go all the way down. The total distance that I move Q to P is 8 meters, right? Correct? So velocity is going to be displacement over time taken. So 8 meters divided by Q to P, how long? 5 seconds. So I get this to be equals to 1.6 meter per second. Okay, can anybody tell me why is this wrong? Why is this wrong? Very good. Because Q to P, you are moving in the backward direction. So kalau you move backward direction is negative, right? Correct. So I use the graph to help me see. If the graph goes up, it's a positive gradient, right? This is a negative gradient, right? So therefore, this is going to be negative 8. So it's a negative 1.6 meter. Then people like to ask me, teacher, kalau I write positive, can teacher, can. So they already say here velocity. Velocity got positive, negative. Unless they ask you, this is speed. Then fine, speed you can write positive, but velocity cannot. This negative diwajibkan. Wajib, okay? Can? Okay. So we go to the next part. We got average speed and average velocity. So how do you calculate average speed and average velocity? So average speed is actually your total distance divided by your this thing called the total time taken. Total distance divided by your total time taken. Okay, how to find your total distance? We actually found already, right? Your total distance studied is how much? 21 meters, right? Why 21 meters? Because 8 plus 8 plus 5. So 21 meters divided by the total time taken. Okay, I teach you the secret here. If you want to find the total time taken of the whole entire motion, you take the last time taken. Because that's the maximum, that's the longest time taken really. So 14 seconds. So this I will get 1.5 meter per second. Can? Okay, what about the total displacement negative 5 meter here? So that is for you to calculate average velocity. Guys, do take note that terdapat perbezaan antara average speed and average velocity. So average speed is total distance. Average velocity is going to be this thing called the total displacement. So if this is total displacement, you have to divide by total time taken. Your total displacement is negative 5 meter displacement. So you will put negative 5 meter divided by the total time taken, 14 seconds. So the total time is the same. Okay. Can you guys help me to calculate this is negative berapa? How much is this? negative 0.357 meter per second. Okay. We write 3 decimal place. Okay, can no problem. Yeah, so that's how it is. Okay, now I give you all 1 minute of mental rest right now. I give you 1 minute of a mental rest right now. Okay, now give me a minute, 1 minute of mental rest. Right? Okay, so far in physics, right? Okay, you guys learn so many stuff already, right? So what seems to be the most difficult thing that you think that you feel like? What's the most difficult thing? But I feel like today everybody who came, right? Wow, you guys very what? So far, what is like the most hardest thing in physics up until this point? Ticker tape. Ticker tape. Okay, but don't worry. Usually ticker tape in SPM, right, very seldom keluar one, okay? But I know, were you here when I told you that I actually have a YouTube channel whereby in my YouTube channel there was this part, okay, I don't know if you watched this before or not, but I know okay, if you go to my YouTube channel, or probably you can type like my name, then belakang you write ticker tape. So there's one part, if you see this one, the one with my hand in the middle, this one. Okay, so the middle one, okay. It says 2.1 ticker tape. That one. Okay, the 9 minutes and 42 seconds. This one, the 8 years ago. I promise you, if you watch that, you will be able to know how to do ticker tape. I promise you this. Sure can. Okay, you try have a look. It's just 9 minutes only. If you times 1.5, you probably finish in like 7 minutes or 6 minutes. Okay, so ticker tape, yeah. So far, a few people watch out. They say boleh faham. Okay, can. Now, anybody got any other things that you think like very susah that you need help or anything? Okay. Preferably before your exams. There's a before your exams, right? Okay. You need to do a bit of extra latihan. So in the middle part here, you see this one. This one. The force and motion part one. The practice with me. This one, the middle one. Yeah, that also you all can watch. That one is 36 minutes of doing essay. Let me think what essay did I do. I think I did some essay questions. Okay, can. Yeah. So I will recommend what you can watch for your exams. All right. Okay. So without further ado, we come back to page 5. Actually, graph, I don't worry because I tell you all one thing the displacement graph, velocity graph, and acceleration graph. That one, right, you will learn in mathematics. Form 4, chapter 7. I think so. So motion graph, so form 4, chapter 6. Form 4, chapter 6. Alright, can. Alright. So you will learn that again. So I'm not worried about this. Okay, so let's look at page 5. Okay, let's look at page 5. Okay, this is a velodrome arena for track cycling. So they will go for track cycling. So these kind of people, they will go cycling. Okay, this is like a hot topic also. Why? Because okay, do you know, right? Physics, they actually will ask issue semester. Okay, they will ask issue semester. So this year for 2024, right? What issue semester are there? Can anybody tell me recently got what issue semester? Or not recently, like this year. What issue semester? What is so special in 2024? That EV car, what EV car? This year 2024 is Olympic lah, okay? Now, because of Olympic, right, a lot of sports related question might come up. Okay, see, you got exam come out sports question, you hear it from me first. Okay, so I'm going to show you this bicycle. So this is also another essay question. Now, can you do me a favor? This is also an essay question. Can you do me a favor? Can you tell me which bicycle track is better? Which track bicycle is better? P, Q, R, or S? So I want you to like gunakan otak and think yang mana lebih bagus. Okay, people choose already. Come on. Wow, this class very cute and we got different answers. We got people choose R, Q, P, and S. We actually got 4 different choices here. Okay, now, for this kind of choosing essay, right, it's a very go big or go home kind of approach. Okay, why I say go big or go home? Because this kind of essay question, right, the moment you choose correctly, okay, let's say 10 marks, kalau you choose correctly, so let's say, okay, let's say S, the moment you choose correctly, automatically, you will get 6 marks. Automatically. Tetapi, if you choose wrongly, gone. Okay, gone. So now, okay, we try to identify certain things first. Okay, I realize here, okay, guys, in these 4 pictures, got how many perbezaan? How many differences are there? In these 4 pictures, how many perbezaan are there? No, it is not 3 differences. Bukan 3. Huh? 6? Oh, not so many lah. Not so many. How many differences are there? The answer is 4. You got see properly not? Okay. So the first one is the handle shape lah. Okay, the handle shape lah. Okay, satu. Dua is which one? The alloy carbon, this one, second. The third is narrow, wide. The fourth is without thread, with thread. So remember, when you look at this kind of question, right, the first thing you have to find is the 4 differences. If you never see properly, if you never distinguish them properly, mana tahu you miss out one chiri, gone. You will lose a lot of marks. Understand what I mean, right? So you make sure that you have to check all 4 first before you continue. Okay, so now we are very messy. Take away first. Okay. So number 1, if you see all these like those cyclists, right, when they go for competition, right, usually the tire very narrow or very wide. The tire very big, like very, when we say wide, we are talking about the width of the thing, like how thick is the tire. So yeah, Caden, it's always very narrow one, right? Right. If diameter, yes, diameter is larger, but wide is no. We want narrow tire. We want narrow tire. Okay, next. Why do we want without thread? The answer is not with thread. Okay, because after I know that this is narrow tire, the second thing is I realize that there is always a drop handle. So drop and handle got what advantage? So you see when they ride bicycle, right? All this when they ride on this bicycle, right? Do you realize that they always bend their body forward? They can drop their body down, right? So the aim is that so that they can become more aerodynamic. Yes, correct. So the answer is actually track bicycle R. You can be more aerodynamic, reduce air resistance. So this one is allow the body to bend into a more aerodynamic shape. So therefore, you can reduce air resistance. Okay, it allows your body to bend into a more slightly aerodynamic shape. Okay, can. Then after that, next, this one is to reduce the friction on the road, on floor. So therefore, you can actually accelerate higher acceleration, go faster. Okay, then why do you want to make out of carbon fiber? Okay, what is carbon fiber famous for? It is very strong and light. Okay, can? Okay, guys, strong or durable also can. Yeah. Guys, is strong the same meaning as hard? Is strong the same meaning as hard? How is it the same? Now the answer is no, not the same. Okay, why not the same? Like I said before, a stone, a batu is strong. I know, right? Batu is hard, but it's not necessarily strong because why? If you take something and whack the stone will pecah. So a stone is hard, but not necessarily strong. Okay, faham? Alright, it's hard but not necessarily strong. Strong is like metal. It's like you whack, it will not pecah. Okay, can, all right. So okay, once you're done with this thing, you have to choose the bicycle track R. So yeah, this one you all try to write yourself. Okay. I don't want to do any writing because later I get you very bored. Okay, once we are done with this thing, okay, I want to ask you another question. Okay, why when they do all this bicycle, right, they will always try to make the tire to have a larger diameter. Okay, just in case they ask, why larger diameter of tire is good? Who can tell me? Why do you want larger diameter? Less force around rotation? No, actually it takes more force. Okay, you all see those like mud rempit. Okay, you guys know what's like mud rempit, right? Like mud rempit, right? They the first thing they change on their car is they will change sport ring lah, wow, the tire very big one lah, wow, the tire go out someone like yeah. Okay, why? Because if it's a small diameter, when you're pushing one circle, it's like very near, right? But if you have a larger tire, if you're pushing one circle, you actually go further, right? Correct? Yeah. So Seng Tian, your answer cannot. But Lion punya, everybody's punya answer like Axel, Caden, Jeshri, Danish, all acceptable. Well done. Okay. So in this case, a larger diameter of tire so that you can actually cover larger distance for one rotation. Or you can say for each rotation. So therefore, it will be able to travel faster. Okay, technically, if you change, or you can say travel at a higher velocity. Technically, let's say today you go to your dad's car or your mom's car, you take the tire out, you change to a bigger tire, let's say 19-inch to change to 20-inch. Automatically, the top speed of the car will increase. Automatically, the top speed of the car will increase. Okay, so make sure you know this thing. Okay. Vincent, you still alive, right? Haven't faint, right? Okay, haven't faint, Okay, let's try one more question. Okay, guys, we are almost at the end already. See, 2 hours are now left half an hour only. Okay, now tinggal half an hour only. Okay, I'm going to do something that most of the people don't like. Okay, what people don't like okay, can we look at page 12? Page 12. 放大一点点。这样子。Boleh. Ya, kira boleh. Okay. Now, once you're done with this, okay, let's go and see page 12. Okay, page 12. Okay. A child and an adult sit on similar swings as shown in diagram 2. So this dewasa duduk sini. Yang kanak-kanak duduk sini. State Newton's first law of motion. Okay, guys. What is Newton's first law of motion? Okay, can I say Newton's first law of motion is inertia? Can or cannot? Can I say Newton's first law of motion is inertia? Because some of them they'll say, teacher, but my school teacher say it's the same lah. Newton's first law of motion is inertia lah. Anybody your school teacher say so? Is inertia. Okay, let's look at the textbook. Let's look at the textbook. According to the textbook, okay, imagine guys, this is a KPM. KPM means this is Kementerian Pelajaran Malaysia. So obviously this is not Jung book. Okay, according to the textbook, it states that concept of inertia dijelaskan. Yeah, this is the BM book. Dijelaskan is related to first law. Dijelaskan dalam, bukan sama dengan. There is a difference between sama dengan and dijelaskan dengan. So this one is dijelaskan dengan. So it's a different thing. Okay. So we cannot say this is inertia because it is not inertia. So remember that you have to memorize all this Newton's first law of motion. Okay. Who can tell me what's Newton's first law of motion without referring to the book? Obviously. Okay, so we will say that your object will remain at rest or move with constant velocity, or it will move with constant velocity when no external force. Certain books, they write no resultant force. So resultant force and your external force is the same thing when there's no external force acting on it. So meaning to say that this object, it will remain. So kalau he's starting at rest, it will remain at rest. What if I write tendency to stay in state of motion? Okay, Regan, that one is the definition for inertia. Tendency is inertia. Because you see, okay, what's the difference between inertia and Newton's first law is Newton's first law, Newton is always got force on. So the definition inside sure got all these external force and everything. Inertia is just a concept. So therefore, it is like, it tend to remain in the state of motion. Okay, so yeah, so for Newton's first law, you have to write the no external force acting. Okay, but that's a very good question. Okay, we good. That's a very good question. Okay, now, so now we see this. Okay, the kanak-kanak and the dewasa and the adult. If you add no external force acting, also cannot, because why? You need to say it is moving at a constant velocity. So technically, right, these two definitions is different. Yeah, walaupun your teacher say it's the same. Okay. Okay, see, when your teacher say the same, right? You ask your teacher, if I write Newton's first law of motion is inertia, will you give me marks? Then you will realize your teacher say, oh, cannot, ini tak boleh tulis macam ni. Yeah. Okay. Now, so if they are given the same push, who is more difficult to move? Who is more difficult to stop? Okay. Now you want to push adult, you want to push a kanak-kanak. Which one difficult to move? Which one more difficult to move? Adult. Which one more difficult to stop? Okay, which one more difficult to move? So obviously this is your adult. Which one more difficult to stop? This is also your adult. Okay, can. Why? Do give a reason. Why? Because the adult has larger mass, so therefore it has a larger inertia. If you have larger mass, obviously you have larger inertia lah. Means you will remain in its original state. Okay, so on. So they ask you for the relationship between inertia and mass, because the higher the mass, if you have the larger the mass, the higher the mass, the higher the inertia. The higher the mass, the higher the inertia. Okay, can? Now, why does a super tanker need to stop its engine over a distance for about 3 km before it can finally come to a stop? Why you need to cover about 3 km before you stop? Yeah. Okay, if you know what's a super tanker, right? Super tanker is not you play Mobile Legends, the tank, that tanker, no. This tank is like the, you know, those big ship, those last time when I was a kid, right? I don't know what this thing fetch on, but only after I study more, that only I know that. So these kind of things, right? They actually ship petrol on you. Do you know that? They actually carry petrol, oil. Obviously, I don't know lah. Okay, I thought it fetch like cargo or something like that. So this is actually they fetch oil. So about 3 km before they sampai the destination, they will off the engine and then let it slowly float all the way to the shore. Okay, why? Because super tanker obviously has a larger mass, so therefore it has a larger inertia. So therefore it requires a longer braking distance. Okay, it requires a longer braking distance. Braking distance means that you need a longer distance to come to a stop. So that's what we mean by longer braking distance. Okay, can I? Okay, so hot topic. Eva, what do you get for your exam? I know you got back your results now. Okay, now, so a petrol tanker truck is used to carry and transport petrol. Okay, this is a petrol tanker truck. Okay. Okay, now, suggest safely designed loaded truck to transport fuel safety. Your answer should be based on the following aspects: compartment of the lorry, braking system, gaps between the truck and the fuel tank, others. Okay, now, this question really was a hot topic. Okay, now, can you tell me, what should you do to the compartment of the lorry? What should you do to the compartment of the lorry? Okay, split into sections. You can say split into sections, you can say split into compartments, you can say split into smaller parts. Apa-apa pun boleh lah. Okay, can, all right. So in this case, I will say that the compartment of the lorry, divided to smaller. Okay, the compartment of lorry divided to smaller tanks, or you can say smaller parts. Smaller tanks or smaller parts. Okay, can, all right. Now, so why do you want to divide this into smaller parts? Different parts, but it's try to say smaller parts because the 重点 is make smaller parts. So guys, remember the word smaller is important. Okay, means you're trying to divide it to become small. So why? So that we can reduce the effect of inertia of petrol in the tank. Okay. Now, do you realize I say something? Reduce the effect of inertia. Why bukan I write to reduce the inertia? Okay, sebenarnya you cannot reduce inertia. Why? Because what mass gives inertia, correct? Mass gives inertia. So why during braking, Jung Hao will fly forward? That is called the effect of inertia. Can I prevent inertia? Can I prevent inertia? Cannot. Mana boleh prevent inertia? Cannot. All I can do is I can reduce the effect of inertia. You understand what I mean? I cannot prevent myself from flying forward. Definitely when I step on the brake, my body will fly forward. But I can prevent, because I fly forward, I fly out of the car. So I prevent from flying out of the car. So that's another advantage of that. So compound small lorry divided into smaller tanks and parts. Okay. Now, number two, what about the braking system? This one very important one. Because in exam, they'll ask you all this braking system stuff. So what should be the braking system here be? Okay, I'll give you a hint. It's ABS. But in exam, you have to write what does ABS means. You cannot just write abs. Later, your teacher asks you why your car must have muscle, must have abs. So why? Advanced braking system? No. No, it's not advanced. Yeah, the one is anti-lock. So the answer is using something what we call anti-lock braking system. Okay. It is not 船 already, it is 车 already. Okay, now, so using anti-lock braking system, we try to elaborate a bit. So it prevents the wheels from locking during braking. Okay, you want to prevent the wheels from locking during braking to prevent skidding. Okay. 打滑 啦, don't say 翻车 啦. Alright, can? Yes. Okay, next. Then we look at the third one. The gaps between the truck and the fuel tank. So the answer is that you need a larger gap between the truck and fuel tank. Okay, when you say the truck actually means truck actually means the kepala of the car. Fuel tank is the behind part here. So they purposely add a bit of gap here. Okay, why? Why do you want a larger gap here? Purpose is what? Okay, so you want to here is to prevent the collision of the fuel tank to the truck, all right, during braking. Okay, because what I'm trying to avoid is, I takut apa berlaku. I takut, right? Like when this big lorry accidentally langgar a tree. Let's say it langgar a tree. So by the time when this car or this lorry hits the tree, you will realize that the back part of the whole entire fuel tank will rush in and crush the front part. Then the person will die, obviously. Okay, can? So I want to prevent the collision of the fuel track to the tractor during braking. So that's what I'm trying to do. Okay. Then lastly, these two. Macam mana? The last two parts is what? You're supposed to give me other suggestions on how to make my fuel tank lorry lebih efficient. Okay, so come on guys. What other things can we say? Wider tire. Okay. Instead of wider tire, we can also say, because I cannot really change the width of a tire, right? I can't make my own tires, right? So in another way to increase the width of the tire, I can do what instead? I don't want to increase the width of the tire. I do something else to increase the width of the tire. So A2, very good. I increase the number of tires. Bermaksud I go and spam more tires. So I get back the same effect, right? So increase the number of tires, I can increase the surface area. Increase the surface area, I can reduce the pressure. So this thing won't pecah lah. Okay, in fact, if you increase the number of tires, you reduce the chance of your tire explode. Yeah, by a lot. Okay, can? Now, so others means that I can increase the number of tires. Increase the number of tires. Remember, don't say width of tire lah. Okay, can? All right. Now, increase number of tires. So what can I do? I can increase the surface area of contact to ground. Okay, I reduce it to ground to reduce the pressure acting on the ground. Okay, can? All right. So I'm trying to do here is I want to increase the surface area of contact to the ground to reduce the pressure acting on the ground. Okay, so that increase area, reduce pressure. So that's the whole point of it lah. Okay, lastly, what other things can we do to the fuel truck? Okay, I Google an image and show you, right? Okay. Do you realize that some of those lorries, right? They will purposely hang something at the back of the car. Like they will hang something like this at the back. Do you realize something like this? Then some they will like put a toy at the back of the lorry. You realize that, right? I don't know if you see it before or not, but if you go and observe, there are actually these kind of things, right? Increase the distance. No, 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 no. It's not it's not that. It's something else. Okay. The purpose of this is we will say to use a small belt, okay, to connect tank to ground. Okay, why? yeah, the aim is to discharge sparks. If you don't say sparks, you can also say to discharge charges so that you can, okay, this is something very similar to what, okay, you pernah dengar what is a earth wire, no? Have you ever heard of what is an earth wire? Okay, so what is it? So when there's extra electric current, this thing will like tarik the current away, right? So this will allow you to discharge sparks, to discharge additional charges. 不是. So therefore, to prevent the petrol from burning in the tank. Okay, next time when you all go to like when you all go to petrol station, right? Correct. You go and see on petrol station when you pump petrol. Okay, when your papa pump petrol, you go and read the sign there, right? So like what no smoking, cannot use handphone, right? Salah satu sign they will say is touch your car before you pump petrol. Touch your creator first. Now, do you know why? Because sometimes your body got static. So if the static accidentally kena the petrol will burn and it will explode on. It will burn and it will explode. That's why you always need to touch the car before you pump petrol. But usually this thing very rare to happen because when you tutup the door, when you close the door, you already touch the car, right? Unless someone help you to close the door, you never touch anything, your body will static. So when you pump petrol, the petrol will explode. So the secret here is touch the car before you pump petrol. Okay, you all don't believe, go and check. Petronas Scotland. Okay, can all right? Can? Okay, now since we have another 10 more minutes, okay, and I want to like make my time worth, okay, I want to finish up the whole entire page. I just want to do all the way down here. It's just calculate. Okay, can? All right. I finish the calculation, then I can end my day already. Okay, I know you guys also penat already. Okay, people nowadays are 1.5 hours sudah complain very tired this that you go to school 6 hours, Okay, now, okay, so what's meant by free fall? Free fall is what? Okay, this definition very important now. It is whereby your object is falling due to gravitational force only without air resistance. Okay, the word is 重点 here is your gravitational force. Okay, the word important here is the gravitational force. Okay, calculate the time taken for the watermelon to reach the frog. Okay, so this is where Jung Hao introduced something called the Suvat. So in this Suvat, what is this Suvat? So the Suvat got a lot of calculation. S equals to ut plus half at squared. S equals to u plus v over 2 times t. V equals to u plus at and v square equals to u square plus 2as. So we got banyak formula dekat sini. Okay, so now what we're going to do here is we're going to check. So I want to find time taken for the watermelon to reach the frog. So that's the time taken unknown. So I will always write unknown for the thing I want to count. 2.5 meter, that is my displacement. S stands for displacement. So when it falls, my initial velocity is 0. U stands for initial is 0. What other things do I have? Acceleration. Acceleration is 9.81. Okay, remember here, when you do this calculation, when you don't have V, you will pick the formula that don't have the alphabet V. So ini tak ada T, ini tak ada S, ini tak ada V, ini tak ada A. So I'm going to use the third formula, which is S equals to UT plus half AT squared. Faham? Okay. So 2.5 equals to 0 multiplied by T half 9.81 T squared. Okay, half 9.1 T squared. So this ini, how much is my T value? Okay, you just going to count this thing off. Okay, while you are calculating this, I'm just going to double check. How many of you got 0.74? How many of you, your school teacher teach you to put negative for 9.1? Anybody here, your school teacher teach you negative 9.1? Ada tak? For dropping down is negative. Okay, nobody. So everybody or teacher positive. Okay, yeah. So you got two choices. It's either both you use positive or one positive, one negative. Faham? You either use both positive or one positive, or both negative. Okay, it's up to you lah. Okay. Next, calculate the velocity of the watermelon just before hitting the floor. Just before hitting the floor. Okay, so we're gonna do SUVAT again. SUVAT. So I'm trying to find the final velocity, 2.5 meters, 0, acceleration 9.81. Time taken, I recount, is 0.714 seconds. Okay, kalau sini all information ada, semua information ada. Which formula should I use? If semua formula ada, which formula should I use? Should I use the first one, second one, third one, or fourth one? Now, Dinesh, do you know why? Okay, a lot of people will say use AT. For me, I will use the first one. I will use without T. Okay, so Dinesh, do you know why without T? Okay, see, in exam, we aim high marks, obviously. So what we want here is we want our answer to be low risk. Kalau you use this V equals to U plus AT, if your time wrong, right, Danish, this time will affect your time also wrong, right? So ini salah, ini pun salah. So when I calculate my velocity, I want to avoid using values that is repeated. So I don't want to use this T value. Mungkin I calculate wrongly. Mana tahu kan? So I will use the V squared equals to U squared plus 2AS to be on the safe side. Okay, Ken? So then I can tell that you are like considered quite high level, high marks with a student. So you need to learn all these like low risk method. So 9.81 bracket S, which is 2.5 meters. So my velocity will be blah, 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 meter per second. 7, okay, 7 meter per second. Okay, Excel, I trust your answer on, Don't throw me, okay, Ken? Yeah, so the answer is 7 meter per second. That's it, very simple. Okay. Yeah, last question for today. As promised, last question for today. Okay. So what is the change in momentum? Now, banyak orang tak tahu, tetapi change in momentum actually means you're supposed to calculate your impulse, which your impulse is actually your mv minus mu, which is your ft is equals to mv minus mu. Now, you don't have to panic. You just have to know, okay, if I want to calculate this, why is this momentum? Why is it change in momentum? Because you take mass times velocity, you take mass times velocity. Okay, the mass here is berapa? 1.5 kg. So the mass here is 1.5 kg minus 1.5 kg, another velocity. Okay, what is the final velocity? Okay, this one quite tricky. Why? Because the final velocity is 0, but the initial velocity is 7. Okay, kenapa? Why this is V7, but this one become U7? Okay, because now this one, we focus on when it hits the floor. When it hits the floor, bermaksud that when your this thing jatuh and it hits the floor. So how fast does it hit the floor? At 7 meters per second. So it will hit the floor at 7 meters per second. Okay, Ken? And then finally, it will stop. So it goes from 7 meters per second to stop when you langgar something. So that's why here you will calculate your answer to be negative. Because your object decelerates. When you hit something, your object slows down. So how much is this? Negative 10.5 lah. What is my unit? Kg meter per second. 10 kg meter per second. Okay, okay, all right. So far so good, everybody. Okay. Last question already, law. Okay, now, so today I hope you learned something. I hope that today you all consider productive or not, guys. Did we do a lot today? I think not bad, right? I think consider not bad, right? Yeah, because we covered quite a lot. Okay. Now, however, if possible, I hope you guys can drop me a subscribe on my YouTube. So I will probably post more Form 4 stuff. Okay. Actually, got people tell me, teacher, your YouTube all Form 5 one, you put a lot of Form 5 stuff lah. Form 4 no need one. Okay. There's a reason why I don't put Form 4 stuff. Do you know why? Because Form 4 people, right, don't study one lah. Where got Form 4 people study one? So Form 5, everybody last minute study. That's why I made quite a lot of Form 5. You see Form 5 Chapter 2, Form 5 Chapter what, but there are some Form 4. You see the latest one are more Form 4 friendly. So if you guys or those people who have exams, you can watch this for your Form 4 chapters. If you guys got no problem, I guess we will sampai sini sahaja. Anybody got any questions? No? So thanks for coming, everybody. Yeah, thanks for coming, everybody. Hope you enjoyed your session today. Hopefully I'll see you again. So bye everyone. Bye bye. 辛苦了大家. Bye bye. Bye everyone. Bye bye. Bye Excel. Bye bye. Bye Kaden. Bye Venice.